Hello mindsetters, I hope you're ready today and you started well with your exams, and I hope you enjoyed your paper 1 mathematics, guys. I encourage you guys to keep using your pen until the last paper. You don't give up, you keep working hard. Keep working hard with your friends, you study a group until you write your final paper, guys. Today, guys, I bring you statistics. I hope you're ready, and you're not going to just to observe. What do? You take a pen and a paper, you try to do the problems. You try to do the problems from you guys. Okay, I hope you're ready. Statistics, guys. Okay, great, fantastic. Let's see. So I have statistics for you guys. So before you make sure, guys, make sure you know how to the following. Find and apply the measure of central tendency. This is your mode, median, and your maximum value, so on, okay? And how to draw and interpret the box and whisker plot, okay? You remember your box and whisker plot. You have a minimum value, the maximum value, lower quartile, and second quartile, and the upper quartile. Then you can draw your whisker plot, guys. Okay, fantastic. Next one, you must how to find and interpret the measure of dispersion. Okay, guys, this is your average, your standard deviation, okay? And interpret the scatter plot of a curve, okay? Great. So by now, I think you've done this. You have an idea what I'm talking about. So let's see what I have. What kind of problems? You try this with me. Next, let's see now. Okay, great. Okay, guys, let's see. Let's start the question 1. Let's see what we can do. Okay, now, read this. The scatter plot below shows the age in years and the average height in centimeter of boys between the age of 12 and 15. Okay, let's see what we have here. So on the x-axis we have ages in years, and on the y-axis you can see that we have the height of a boy. So for any x value, then the output on the y is the height of the boy. Okay, so let's see what they want here. The first question is, use the scatter plot. Use the scatter plot to determine the average height of a 7-year-old boy. Let's see what it means. For a 2-year-old boy, there's the average height of a boy. For a 3-year-old boy, that is the average height for that boy. Okay, so now what do we want? We want the average height for a 7-year-old boy. So we go to 7. So if you see, there is 7. On the y-axis, what is the corresponding y value, corresponding height? So if you take 7, the corresponding height is there somewhere, is approximately 21 centimeter. So this is approximately 121 centimeter, 121 centimeter, and I think 122 is also acceptable. Okay, good, fantastic. I hope you understand this. What I did, I went to my x-axis, because x-axis I have the age of a boy and the corresponding on the y, which is the height. Okay, good. And the next question, describe the trend of the scatter. What does it mean? What does it mean? By looking at this dots, what can we describe here? What is really happening? Let's say these dots were all over the Cartesian plane. I mean, there'll be no correlation. Can I try to fit a straight line? No. Maybe in this case, I mean, it's close to a straight line. I mean, I can fit a straight line, but not exactly a straight line, but a much, much better straight line. So I can describe this as a positive correlation, because the gradient of this is positive, and I can say this is a positive correlation. So this is a positive correlation. What do I mean? If I can draw a straight line, the points, they'll be close to the straight line. So it's a strong positive correlation. Okay, great. Now, the next question. What is the approximate increase in the average height per annum between the age of 2 and 15 years? So the question, what is the average increase? This is just asking, what is the average, what is increase? What is the average gradient of this? If I can draw a straight line, the best I can fit a straight line. But what is the average gradient of this? What do I need to find a gradient? I need 2 points on that line. And I can use my gradient formula, which is what? Change in y over change in x. Okay, let's see what I can do. So to find the average gradient for this will be the average gradient. So let me take, in this case, if I take this as a point, if I take this point, what are the coordinates for that point? So this is 2 and approximately 86. I can try and use that point. Let me take that point. You just need any 2 points on that best fit line. So I can take that point and let me take the 15 one. So the 15, so here on the x-axis I have 15. On the y-axis I have approximately 168. 168, it's close enough, I think. Okay, then from there I calculate the gradient using the 2 points. So you know the gradient, my gradient formula. So the average increase, so the average increase, the approximate increase, the increase in this case is equals to the change in y over change in x. So what is my change in y? 168 minus 86. So 168 minus, what is the other change in y? 168 minus 86. This is your change in y over change in x. What is my change in x? Change in x is 15 minus 2. So it's 15 minus 2. Okay, then you can put this in a calculator straightforward. So I have this 168 minus 86 over 15 minus 2, and you can put this, and this is approximately 6.3. So this is 6.3. This is your average increase for your height. Okay, that makes sense, guys. Okay, you just use the gradient. Gradient is change in y over change in x. In this case, our y is the height and the x is the age of the boys. Okay, good. Now, 1.4, explain why the observed trend cannot continue indefinitely. Can this continue like this? Can this scatter plot continue like this forever? Let's see. What does it mean? When a boy is 2 years old, he's approximately 80-something centimeters, 3 years, 95. Can this continue like this? Definitely no. I mean, when you get old, your approach is set and constant. You don't get tall anymore. So this will not continue like this, okay? It's true for 2 years to 15 years, but after 15 years, it might not work the same, okay? So this is, explain why this cannot continue, because the approach is set in height. This will not continue. The height does not continue indefinitely, guys, okay? I hope you understand this. Okay, good. Let's see the next question. What do we have here? Okay. Next question. And I encourage you guys again, you read the whole question. You read the whole question. Don't try to, and if you can't do 1.1, do the next problem. Let's see what we have in question 2. Abe plays for his school. Okay, he plays for his school. He plays cricket. The number of runs scored by Abe's in the 8 games. So he played 8 games. This is very important. 8 games that he batted is shown below. So what happened? Abe's played cricket, and his first game he had 21 runs. Second game 8 runs, and 19 runs, and 7 runs, and so on. Okay. The first question, determine the average run scored by Abe in the 8 games. What is the average? We need to calculate the average for the 8 games. How do you calculate the average? You take your data, you add all the numbers, divided by how many numbers you have. Okay, so what do we have? How many numbers do you have here? We have 8. So we have 8 there. So you have to add all this and divide by 8. So let's see. So this is the formula. X bar, which is sigma x over N. Now, if you check in my calculator there, you have the match. So how do you set this in a test mode? So select mode. Let's select mode. There I select mode. I get 3 options. So you select what? Option 2, which is stats. So I select option 2. Then I get lots and lots of options. So select option 1. So if you select option 1, you get your table. So what you can do, you can put all your data in that table. So let's put our data. So the first number is what? 21. I have to put 21, 8, 19, everything in that calculator. So let's see. I start with 2, 1. I say 2, 1. Then you say equal to. Then the next number is 8. Then you put 8. Then you say equals to. Then the next number, which is 19, you put 19. You say 1, 9. Then you put your equal to. Then what is the next number? 7. You put 7. Then you say 7. Then equal to. The next number is 15. Then we have 15 equal to. Then the next number we have is 32. Then 32. After 32, we have 14. Then 12. Okay, I have all my data now on the table. Okay, so what do you do now? You press this button, the AC button. The AC button like stores that data. So you say AC button. Okay, then what do you do now? After AC, shift, then option 1. Can you see option 1 with stats? Option 1. Then after you get 5 options. So you select option 4, the var, VAR, option 4, option 4. So if you select option 4, you get the first one is how many numbers you have in your data set. Option 2 is your average. And option 3, which is your standard deviation, we shall be doing later. I think option 4 is the population deviation. So now we want option 2. So option 2, then equal to, then we get that our average is 16. Okay, good. So the average is 16. What you can do, you can add this divided by 8. You will get 16 as your average. Okay, good. The next question, determine the standard deviation of the data set. So the standard deviation also, you use your calculator. What is nice about this, the calculator already stored that data, the same data, so I can recall the data and calculate the standard deviation. Let's see how can I do this. So I take out my calculator. I already have the previous data. So what do? You say shift 1, which is stats. Then what do? You select option 4 again, option 4. Then you remember, you still have that data. The data from the previous question, because we use the same data to calculate the average. Now we use the same data to calculate the standard deviation. The standard deviation, how far are we from the average? Okay, so the standard deviation is option 3. Option 3, then equal to, you get 7.55 as your standard deviation. Okay, so your standard deviation is 7.55. Therefore, the standard deviation, the standard deviation in this case is 7.55. Okay, good. I hope you understand this, guys. Use your calculator to calculate the average and to calculate the standard deviation. Okay, hope it makes sense. Nice. 2.3. Now, it's the same problem, same question from 1.1, 1.2, 1.3. Okay. Now, let's see. Abe's score for the first 3 games of the next 8 games. So for the next games, he scores 22, 35, and 2 respectively. So you play another games, 3 games from the same data, then you get 22 runs, and 35 runs, and 2 runs. Describe the effect of his performance on the standard deviation. After standard deviation set for 11 data set. Okay, so now the first question, we had 8 runs. Now Abe goes again and play cricket and 3 more runs. Now we want to know the effect of standard deviation. What is the effect to the standard deviation? So on our data set, we have to add this, 22, 35, and 2, and calculate the standard deviation again using the calculator and see the effect. Will the standard deviation increase, decrease? Let's see. I'm not sure now. So from the same data set, we add our data, we add with 30, which is 22, we add this with 22, 35, and 2, because it goes again, play cricket again. Then what? You get 22 runs, 35 runs, and 2 runs. What is the effect on the standard deviation if you play 3 more games and get 22 runs, 35 runs, and 2 runs? Let's see now. Let's calculate the standard deviation again using a calculator. Take out my calculator. I'm still on stats mode. I can cancel this. Mode, stats 1. Again, then I can enter my data again, which is 21 equals to 8, then 19, 7, 15, and let me pull this, 15. Then I have, after 15, I have 32, then after 32, I have 14, I put 14, 12, then 22, then 10, after 10th is 35, then 2. Same procedure, you enter your data, then you press what? AC, then I recall the data now, shift 1, then remember option what? 4, then I select option 4, then I want what? The standard deviation, option 3, which is equals to, then the standard deviation is 9.7 now. Okay, so what does it mean? After playing 3 more games, we gather the standard deviation. The standard deviation. The standard deviation of Abe now is 9.7. 9.7 now. What does it mean? The standard deviation increased. Increased. Okay, good. I hope it makes sense, guys. What I did, you play 3 more games. What is the effect to standard deviation? Put the 3 more data, then calculate the standard deviation. Then the standard deviation increase. Okay, nice, great. Now, let's see, 2.4. 2.4 now. Abe hoped to score an average of 20 runs. What is the average? You add everything. You divide by how many numbers you have. So he hopes to score an average of 20 runs in 16 games. In 16 games. What should his average in the last 5 games so that he might reach his goal? So now Abe wants to play 16 games. After playing 16 games, he aims to have an average of 20. Let's see now. So from our data set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So how many games does he want to play more? 5 more games. But he wants to get certain runs such a way that his average is 20. So what does he want? He wants this. Let's see, what does he want, Abes? He wants to play 5 more games. We don't know, and get another run, which you don't know. We can let it be X. Another run can be X, and X, and X, and X. 5 more runs to make 16 so that the average can be 20. So let's see if this is 16 games. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have to add all this. So I have to add all this. Let's see. I have to add all this data divided by 16 must give me 20. So I have to solve X in this case. So let me use my calculator just to add the numbers. So if I add all these numbers, cancel this. Remember, guys, cancel this. Remember how to take off your calc from state mode. Now you're writing your trick. You've been doing stats now. Your calculator's in the stats modes. You don't want stats modes. How do you do that? You have to go back to the normal math. You say mode, select option 1. Select option 1. Now you don't have the stats modes again, you have the maths. So I want to add the sum of this.
And in 3, 2, 1.
Okay, now let's add the numbers. So I have 2, 1 plus 8 plus 19, 7. Then after 7, let me see what I have. 15. I have 15. I have plus 1, 5. Then 32. Then you have plus 32. Then after 32, you have 14 plus 1, 4 and 12 and plus 12. Then after 12, we have 22. We have 22. Then I add 2, 2 plus 35 plus 2. Then I press my equals to. Then I get 187. What does it mean? So this, the sum of this, 187. This is 187. So I must add this 187 plus 5x, because 5 more games over. Let's see how many games we have in total. Let's see how many now from the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this over 16 must give me an average of 20. Okay, so we want to calculate the value of x. So I can just multiply this by 20. So 16 times 20, you can use your calculator. Don't be afraid to use a calculator. So 16 times 20, I get 320. So I have 187, 5x, then 320, then 5x is what? Let's see, 320 minus 187. X is 320 minus 187 over 5. Put this in a calculator and let's see what we get. So you put this button, 320 minus 187 over 5. Okay, over 5. Let's see what we get. We get 26.6. So Abe needs for the next 5 games, he needs more than 26.6 runs per game. So I actually need like 26 runs for any game to achieve an average of 20 in 16 games. Okay, guys. Hope you enjoy this, guys. Let's see now, and I hope you enjoy. I'm taking a short break now, and I'll see you after break with more questions, guys. Okay, good. Welcome again, man setters. Hope you're ready again, guys. We have another question on statistics. Hope you try this with the pen and paper with me. And you know what? We don't relax until we write our final paper. Okay, let's see what I have. Okay, remember, you read the whole problem before you try to do anything. If you can solve a question, it's nothing bad. Don't waste time trying to do the question. Do the next problem, then you'll come back later. Okay, let's see what I have here. Question 3. Very important to read again. In a certain school, 16 learners wrote examination in mathematics and physical science. The box and whisker diagram below shows the marks out of 100. And this learner scored in physical science examination. And remember, with the whisker box, then what do I think? I think about the 5-number summary by just looking at the whisker box, okay? Now, let's see that first problem. The first problem. So, what does it mean? So, there is my whisker box. What I was talking about. We'll look at the whisker box. I see the minimum value there. I see maximum value. I see lower quartile or first quartile. I see my median or second quartile, the upper quartile or the third quartile. So I have my 5-number summary. Okay, now, what is the first question? Write down the range of the marks scored in this science. So, what is the range? Range is equals to the maximum value minus the minimum value. what is the maximum value in this case? The maximum value is 85. I have 85 in maximum value, and my minimum value is 30. Then you minus this, then what do you get? You get 55 is your range. The range is the maximum value minus the minimum value. Okay, good. Next question. Use the information below to draw box and whisker diagram for mathematics results on the diagram sheet 1. So I have to use this information to draw the whisker diagram. Remember, to draw the whisker diagram, you need minimum value, maximum value, your lower quartile, your median, and your upper quartile. Okay, so what do we have here? Oh, minimum value. I already have my minimum value. Great. I have my minimum value. Range. Will the range be in the whisker plot? No. But given the minimum value and the range, I can find what? The maximum value. Agree. Let's see how can we do this. So remember that the range is equal to the maximum value minus the minimum value. So the range in this case is 55. What is the maximum value? I don't know. So I put maximum value there. What is the minimum value? Minus 30. Then I solve an equation. I move my 30 that side, and I get maximum is 85. Therefore, maximum value is equal to 55 plus 30. You get is 85. So the maximum value, now I'm happy. I have my minimum and my maximum. So what I can do, I can go there and say, okay, what is my maximum value and my minimum value? My minimum value is 30. I can put a dot there. And what is my maximum value? I can put 85. So I have my minimum value and maximum value. What do I need now? The lower quartile, median, and the upper quartile. Okay, so now let's check up there. I have the upper quartile. Good. Does the upper quartile go? Yes. So the upper quartile is 70. So you go there, you draw a line like this. So you get your upper quartile there, 70. So I have my upper quartile. So I've used, let me check, I've used that. My median is 55. Where does the median go? 55. There's my median. My median is 55. My median is 55. I need my lower quartile now. Let's see. How can I get my lower quartile? I don't have a lower quartile in this case, but I have the upper quartile and interquartile range. So how do you work out interquartile range? Remember, interquartile range is the upper quartile minus the lower quartile. So I have interquartile range and the upper quartile, so I can work out the lower quartile. Let's see, how can I do this? So interquartile range, let me say interquartile range is the upper quartile, which is Q3 minus Q1. So I want Q1. So I want Q1 in this case. So Q1 is, I can bring this side. Let me bring this side and bring this side. So Q1 is equal to Q3 minus interquartile range. So what is Q3? So my Q3, which is 70, so I have 70 minus interquartile range. What is interquartile range? It's just 30. Then I get 40 is my lower quartile. So the lower quartile, or the first quartile, is 40 there. Then I can complete my whisker plot and say this is there. Then I have this. I complete this. Okay, so this is what you have. This is your whisker plot. Your minimum value, lower quartile, your median, your upper quartile, and your maximum value, your 5-number summary. Okay, great, fantastic. Okay, now from this, by looking at this, let's look at 3.3. How many learners scored less than 70% in mathematics examination? Remember, this is mathematics examination, and this is maths, and this is your physical science examination. So how many learners score this? So if you check, 85% of the learner, because remember, your lower quartile takes 25% of your data. Your second quartile, or median, is 50% of the data. And the upper quartile, what does it do? 75% of the data. And remember, the interquartile range is very good. It works with the 50% of the data because your upper quartile minus your lower quartile is between the 50% of your data. So 75% of this, 75% of learners scored less than 70% for this test. Why? Why 75%? Because the upper quartile is 70. It's 70 there. So that's the highest value. Then from there, I have lower value than that. So what does it mean? Now, how many learners scored less than this? So less than 70% is actually 75 over 100 times how many learners we have in a class. We have 60 learners in a class. So we have 60 learners in a class. We have times 60. So you can just put this in a calculator and get the answer for this. So I cancel this. Then what I have 75 over 100. Then I can say equals to times 60. Then you get 45. Learners scored less than 70% for this mathematics examination. Okay, great. Okay, now let's check the next question. Okay. Joe claims that the numbers of learners who scored 30 and 40 in science is smaller than the numbers of learners who scored between 30 and 55 in maths. Okay, so Joe claims that 30 to 45 in physical science. He claims that numbers who scored 30 and 45% in physical science is smaller than the numbers scored between 30 and 55 in science. Let's see. So I think Joe's claim is invalid. Joe's claim is invalid. If you check the science, almost this part of the whisker is almost equals to that. So the Joe's claim is invalid. Almost the science is symmetric, okay? It's symmetric, so this is invalid claim. This is not 2. This is invalid claim from Joe. Okay. I hope it makes sense. If you look at the science, it's almost symmetric. 50% of the data is there, 50% of the data is there. So 30 to 50 in physical science is not smaller. This is not smaller than that by just comparing the two whisker plot. Okay, good. Hope it makes sense. Now, let's look what I have, the next question. So question 4. I encourage again, guys, it's very important you read the whole problem before you try and solve everything. Most of you, I know, you jump into trying to do 4.1. Try to read and make sense of it. If you struggle to next problem, you might understand. Don't waste time. Okay, remember, you have to get maximum marks as possible for your examination. Let's see what I have. Question 4. Question 4. As part of environment and awareness, initiative. Learners of Greenside High School, okay? We're asked to collect newspaper for recycling. The cumulative frequency graph, or the ogive below, shows the total weight of newspaper in kilogram collected over 6 months by 30 learners. Let's see what they want now. Okay, there I have my cumulative frequency. I have numbers of weight of newspaper collected in kilogram, and on my y-axis I have my cumulative frequency. So let's just read what they want. The first question, determine the modal class. Okay, what is the modal class? Remember, the modal class, I can get the modal class when the data is group data. The group data, the one with the highest frequency, then is your modal class. But when I have a data like 1, 2, 3, 4, 5 ungrouped data, I can get a mode. Okay, I can get my mode. If I have 1, 2, 3, 4, 5, and another 5, then 5 is my mode. Okay, then you can have 2 mode, which is called bimodal. Okay, but if you have more than 3 mode, you don't have a mode completely. Okay, so in this case, we want a modal class. How do we find the modal class? Let's see. Look at the cumulative frequency. So the modal class, in this case, can you see, it lies where there's a huge gap. Can you see there? My modal class is there. It's between 50 and 60. So you can write your modal class by reading it from your cumulative frequency. You can say 50 to 60 is your modal class. You can write it this way. Or what you can do, you can write it this way. It's also acceptable. This is okay. Or you can say 50 included, but 60 not included. This is acceptable. Remember, you have to choose one. Or you can say also, you can say include the 60, but exclude the 50. So one of this is correct. That is your modal class in this case. Okay, good. Next problem. Determine the median weight of the newspaper collected by the group. What is the median? We want the median weight. If you have a cumulative frequency, from a cumulative frequency, you can calculate your lower quartile, your median, and your upper quartile by using the cumulative frequency. So let me look at my cumulative frequency. See, how can I do this? If you look at a cumulative frequency, it ranges from 0 to 30. The cumulative frequency from 0 to 30. It ranges from there. So what is halfway through 0 and 30 is what? It's 15. This value, the corresponding value for this, you draw with the ruler, get to that line there, and you go down. If you go down there, then that value, which is this value, is your median. Is your median. In this case, is 52, approximately 52. So 52 kilogram is your median in this case, guys. Hope it makes sense. Okay, so if I have my cumulative frequency, how do I get my median? Because this cumulative frequency, you check it, starts from 0 and it ends at 30. So halfway through this, which is 15, I read off the graph, then I get 52, which is my median. Next question. How many learners collected more than 60? How many learners collected more than 60 kilogram of newspaper? More than 60 kilograms of newspaper. What do? More than 60 kilogram. More than 60 kilogram. It's there. More than 60 kilogram. It's right there. Everyone there. So what do? How do you find that? How many learners collected more than 60 kilogram? You read that value. This value is around, so I think is more than 60 kilogram. Read off 60. If I read off 60, I get 1, 2, 21, 22, 23. I get 23 there. And if I read off at 90 there, if I read up at 90, I get approximately 30. So I get 30. So land is collected more than 60 kilogram. It should be our 30 minus 23. So which is 30 minus 23, then which you get 7 lands. Okay, guys, I hope this makes sense. Now, let me go back. I don't have this question there. Go back and how do I find lower quartile? Using the cumulative frequency, you can do that. How do you find the upper quartile? Using the cumulative frequency. We can ask also, find the interquartile range using the cumulative frequency, which is what? The upper quartile minus the lower quartile. Let's do this. Okay. So if I have my cumulative frequency, you check this again. Halfway through this, which is 15, you get a median. Then halfway through this, from there to there, you will get your lower, you'll read your lower quartile. So half of this is 7.5. Around there, let me use a different color. Around there, you get 7.5. So if I, with your ruler, go this way, you go there, then you go down. Approximately 45. 45 is our lower quartile. So Q1, let me write my Q1. So my Q1, just doing this with the, so Q1 is 45 kilogram. You can read this from, I read this from the graph. How do I do this? Lower quartile. Then how can I find the upper quartile? It's halfway. This side also, this level, from 15 to 30. Where's halfway through that? You take your ruler, remember you do with this ruler, you draw straight to the ruler. After drawing straight to the ruler, you get there, you go down there. What do? I get 60. 60 is my third quartile. So Q3, 60 kilogram. You can get my upper quartile also from the cumulative frequency. Then how do you get the interquartile range? The interquartile range is what? The interquartile range is what? 60 minus 45, which is I get 15. Remember, the interquartile range, what does it do? It's actually the range of 50% of the data. It's actually good. It's exclude 25% of the data on the upper bound and 25% of the data. Okay. Thank you guys for joining us today. I hope you enjoy the stats and you're working hard for your final exam papers, and I hope you started well. I mean, you don't put your pen down until you write that final paper, guys. I hope to see you sometimes, guys. Keep working hard, and thank you for joining us today. Fantastic. Good.